Today is solving polynomials, okay? So page 83, 226, 18. All right, so before we do a whole lot to solve each equation, what we're finding is zeros. We're finding zeros. Zeros are the values of either x or r or whatever. When plugged in, makes it zero. I mean, what values of r will make this thing zero, okay? Now, because it's a r the cubed, in this case, there's going to be 3 zeros, okay? It's got a cube, so I know for sure in this example there's going to be 3 zeros. So we're going to solve it. One way to solve it is by factoring. Well, I can factor that. I can. Let me put a 1 here to help me out. Right? And I'm going to look at it. I'm going to first common factor. They both have a r in common, so I'll take out an r. And then I'll have a 36r squared minus 1. It can be factored again. So I'll have an r, and I'll have a 6r plus 1, and a 6r minus 1, okay? Now, what I have is 3 little mini equations equal to 0. I've got 3 mini equations equal to 0, so I'm going to solve all 3 of my mini equations and have my 3 answers, or my 3 zeros. Okay, so the first one's pretty much solved for, r equals 0. Well, that's pretty much done. There's one of my zeros. 0 is a 0. 6r plus 1 equals 0, and 6r minus 1 equals 0, giving me my other 2 zeros. Okay, so I've got one of them solved. I'm just going to solve the second one. And then I'll solve the third one, and I'll get all 3 zeros. Okay, so on this one I'll go minus 1, and I'll have a 6r equals 1, divide by 6, and I get r equals 1/6. That's my second 0. Okay. My third 0 comes from my third little mini equation. I'll go plus 1, the 6r equals 1. Divide by 6, and my other one is a minus 6. This one should have been a minus. This should have been a minus because of minus 1 there. And positive 1/6. So my 3 zeros are 0, negative 1/6, and 1/6. Okay? Thumbs up? Okay? So we're going to do the same thing. We're going to try and find our zeros. Okay? So I kind of want to do 4, but I squished it in there. So let's do 3. Let's do 3, because we got room for 3. Slide 3 over. Am I going too fast? Slide 3 over. So again, if we want to find the zeros, let's make it equal to 0. Does that make sense? So I'm going to bring the 3m squared to the other side to make it equal to 0. If I want to find zeros, let's make it equal 0. So a 0 equals a 75m to the 4th minus a 3m squared. I know there's going to be 4 answers. There's going to be 4 answers for sure. There's going to be 4 zeros because of the m to the 4th. So first thing I'm going to do is factor out a, how about a 3m? How about 3m squared? How about a 3m squared? And I'm going to have a parentheses, 3m squared. I'll have a 25m squared minus 1. I think I can factor again. That'll be a 5m plus 1, 5m minus 1. So my 3m squared is still on the outside because I pulled that out. But now I'm going to factor that into a 5m plus 1 and a 5m minus 1. And then I've got my little mini equations. I just have to set them equal to 0 and solve. So I'll take my 3m, set it equals 0, 5m plus 1, set it equals 0, and my 5m minus 1, set it equals 0. So I'll do that down here. 0 equals 3m squared. I'll have 0 equals 5m plus 1. And I'll do the other one, I'll squeeze the other one down here. 0 equals 5m minus 1. Okay? So I'm going to solve. So if I divide by 3, I'm going to get 0 equals m squared. Square root, that's just 0. Okay? Now, because it was an m squared, I should have two answers. So it happened twice. So we're going to call that a double. We're going to call it a double root. Eventually, we'll call it a double 0 for now. That's going to be a double. We're going to call it a double because we had two of them and it happened twice. 0 happened twice. On this one, we'll go minus 1, negative 1 equals 5m. Divide, and I get negative 1/5. That's my other 0. Here we'll go plus 1, divide by 5, and we get 1/5, okay? So, 0, but 0 happened twice, negative 1/5, and positive 1/5, okay? Now, what these are as zeros, it's where the y is 0, which makes them also x-intercepts. So zeros are also x-intercepts. Okay? Zeros are also called x-intercepts. So we're going to graph the next couple without our calculator, because we can do it without our calculator. Okay, we really can. So if I'm going to find the zeros, let's set it equal to 0, okay? Set it equal to 0. So 0 equals x to the fourth minus x cubed minus 12x squared. Now there should be 4 zeros. So the first thing I do is I'm going to go ahead and factor out an x squared, right? So if I factor out an x squared, I'm going to have an x squared minus a 1x minus a 12. Smart girl.
It was smart.
Yep. So then I have 0 equals x squared times x minus 4, x plus 3, okay? Now, we're in Algebra 2. We can do the next step in our head. Really. I mean, if I solve for x squared, what are you going to get? You're going to get a 0, right? Get a 0 from here. X squared equals 0, right? You're going to get a 0 twice. We're going to get 0. One answer is x equals 0. X equals 0 twice. What's the answer here going to be? 4. You guys agree? 4? Because you'd set that equal to 0 and you go plus 4, so we'd get x equals 4. What's the answer here if I solved it in my head? Negative 3, right? Minus 3, you get x equals negative 3. Or it's just the opposite, right? Okay, let's see how that works as far as graphing, right? Okay. All right, so I'm going to have a 0 at 1, 2, 3, 4, okay? I'm going to have a 0 at 0 twice, and I'm going to have a 0 at negative 3, okay? Now, here's how the graph works. I don't need a calculator to graph this. I really don't. I know that it's going to take here and it's going to take off for infinity. It has to, because it's a positive x fourth. So in the very end, it's taken off to infinity. Remember how you talked about that? So it's got to go through this one right here, okay? Now it's going to go down, and it's going to come back up, and it's going to go through this. Now use your imagination. I want you to watch this. It's going to go through this point, and it's got to go through it again, because 0 happened twice. How can it go through this point and then go through it again? It's going to go up through it, and then back down. Watch me draw it. It went through it, and then back down, because it happened twice. That's what we call a double root. See, I went through that point, 0, and then through it again, which means back down. This one comes back up, it goes like that. So if you were to graph this original, it'd look exactly like that. We can do it without a calculator. Okay, let's do one more of those. Let's take a look at number 8. Okay, I'm going to do one more of those. Okay, am I going too fast? Okay, number 8. So if I want to find zeros, let's set it equal to 0, right? 0 equals a negative 4x cubed plus 12x squared minus 9x. Okay, if I'm looking for zeros, set it equal to 0, okay? There's going to be 3 answers. Okay, 3 answers. So the first thing I'm going to do is factor out, let's take out an x. To make it easy for me, I'm just going to take out a negative x. Okay, if I take out a negative x? I don't like negatives. I don't like no stinking negatives. Negative x. I know. Glad you're listening. So if I take out a negative x out of these, that would give me a 4x squared minus a 12 2x plus 9. This should factor again. In fact, I think it factors into this. 2x, 2x, minus 3, minus 3. Okay, I've got many equations, don't I? I've got 3 mini equations. One will solve 0 equals negative x. Another will solve 0 equals 2x minus 3. And the other will solve 0 equals 2x plus 3. Nope, minus 3 also. My bad. It is minus 3. I'm getting sloppy. So let's solve these. That's solved x equals 0. Plus 3 plus 3. Divide by 2, I got 1.5. Plus 3, divide by 2, I get a 1.5. Okay. Now graph in number 8. Am I going too fast? Okay. Let's graph it. Okay. So I know for sure the graph goes through at 0. It goes through at 0. It goes through at 1.5 twice. Twice. Okay. Now I'm going to highlight something. See that negative? Because that's negative, in the end it's going to take a dive. In the end, it's going to take a dive. So I know the graph is going to go down. Because at the end it's negative. Now it's got to go through this point twice. So it normally would go up through it and come back down. Now listen, it normally goes up through it, but it's got to go through it twice. So it goes up through it and then back down. So this is where you call it double root. So it went through it again, and then it goes up through the 0. That's what that graph has to look like, okay? All right, let's turn the page, and we're almost done, okay? Okay. Let's take a look at number 13. We're almost done. Okay. So write a polynomial function, okay, of least degree that has rational coefficients, a leading coefficient of 1 and zeros of negative 5 and 4 plus the square root of 2, okay? All right, so I know that we're going to start with this. The only way I can get an answer of negative 5, is if it came from an x plus 5, okay? Because x plus 5 would give me an answer of negative 5, wouldn't it? This one's a little tricky. This 4 plus square root of 2, there's also a 4 minus the square root of 2, okay? So then I would have a x minus a 4 minus the square root of 2, and an x minus a 4 plus a square root of 2, and all that, if u equals 0, would get you these answers. All right, so let's make this p of x equals that, okay? That's not a very good looking thing, is it? Do you mind if I fix this? It's a terrible answer, okay? So let's see what happens if I FOIL this. X squared minus 4x plus the square root of 2x minus 4x minus 4 square root of 2 minus 16, and then minus the square root of 2x, positive 4 square root of 2, and then minus the square root of 4. Wow, that's kind of a mess. Let's see what we've got. So I'd have an x squared, cancel, minus 4x, cancel. Oh, the square root of 4 is 2, isn't it? Square root of 4 is 2, isn't that 2?
Yeah.
So 16, negative 16, negative 2 makes it negative 18. Here's my polynomial. Great extra credit problem, isn't it? Isn't that a great extra credit problem?
Why did you put the square root of 2x things underneath?
They canceled. One's positive, one's negative.
Well, why did you put them underneath there?
Oh, because I knew they were the same. I line them up. So, Braylon, whenever I do this multiply, I try and put the ones the same together because it makes it easier. Like I put these two the same because they're equal to. So I got a positive 4, right? And if I line them up, then it's easier to add them. Just makes it easy for me to add them. If I put the same things together, that's why I did it, okay? All right, so that was a hard problem. That would be a great problem on extra credit, wouldn't you agree?
No.